So while the world has been buzzing about AI software, all the language models, the generative stuff, the generational revolution is happening in concrete and steel.
Exactly. It's the physical brains of AI.
Right. And if you ask someone to picture a really complex build, what do they think of? A hospital, maybe?
Yeah, a hospital with all its medical gas piping or a huge skyscraper. But, try building something that draws the electrical load of a small city, cools thousands of chips running hotter than anything ever made.
And has to be built, like yesterday.
Precisely. That's the hyperscale data center boom.
And the scale of the investment is it's staggering. We pulled the latest numbers and they tell the story. Data center construction spending hit, a record $14 billion?
In a single month.
Yeah.
July 2025. That nearly doubled the previous monthly high.
And that's not a blip.
No, not a fluke. The projection for all of 2025 is already over $46 billion.
Today's episode is brought to you by SmartBusinessAutomator.com, the operations engine behind modern construction firms that want to scale smarter, not harder. If you're dealing with project delays, chaotic scheduling, drop balls on follow-ups, or manual bottlenecks, Smart Business Automator helps you automate back-office workflows and change order follow-ups, streamline subcontractor coordination and client communication, track bids, leads, and financials in one clean dashboard. Free up your time to focus on building, hiring, and closing bigger deals. Because in construction, scale without systems is just stress. Now, let's deep dive.
This is a historic transformation of our infrastructure.
Critically, these new builds aren't just bigger boxes. The shift is toward far larger, much more complex facilities.
Oh, yeah. Which has driven the average construction cost for just one data center to a record. What is it, $220 million?
Yeah.
You're building industrial-grade infrastructure now.
So our mission for you today is to do a pragmatic deep dive into the mechanical, electrical, and plumbing, the MEP opportunities that are absolutely exploding here.
But we also have to talk about the risks, the huge construction and political risks you have to manage to actually profit in this AI gold rush.
We're here to connect the dots between those headlines about generative AI and the complex high-margin contracts that should be on your desk.
Let's start at the root cause of it all, the speed of the AI chip itself.
Okay, let's unpack that. The semiconductor tech is just relentless. We're seeing computation tasks that used to take like 32 hours.
Right.
Now they're being done in just 1 second with the latest GPUs. The chips are getting smarter, faster, and much, much hotter.
And that exponential speed, the ability to train on these huge data sets, it just fundamentally redefines what the infrastructure has to be.
Which leads to the problem everyone is talking about.
Power scarcity. Global data center energy demand is now forecast to double in the next 5 years. That's straining traditional power grids, and it's causing serious public pushback.
And this isn't just a few complaints. It's an organized political force now. A coalition of over 230 environmental groups has demanded a national moratorium on new data centers.
They're blaming these projects for jacking up residential electricity bills and, worsening the climate crisis. The projection is an extra 44 million tons of CO2 by 2030.
Which is like putting, 10 million extra cars on the road?
Exactly. And this is a material risk. It's not just a headline. Local opposition has already blocked or delayed at least 16 major projects.
16. Where's a combined $64 billion in planned value?
Yeah. It's moved from just an environmental issue to a political one. You have local candidates winning elections by campaigning against data center demand and rising utility bills.
Okay, but here's where it gets interesting for our listeners in the construction industry. This huge problem, the power scarcity, the regulatory headache, that's actually the opportunity.
I hadn't quite thought of it that way. The political leverage it gives builders. How does that work? How does a 4-year permitting backlog for a utility upgrade turn into a better contract for a GC?
Well, the main bottleneck isn't material or labor anymore, it's the regulatory delay. Securing easements, getting approvals for new transmission lines, that can easily take 4 years or more.
And equipment like high voltage transformers is scarce, I imagine?
It is, but the main delay is the red tape. And that time lag forces developers to look inward. They have to pay a premium for a general contractor who can do the full EPC engineering, procurement, and construction for a private power generation facility.
That's the pivot. The developer can't rely on the grid, so the data center has to become its own microgrid. Suddenly, you're not just hooking up to a utility pole, you're an energy engineer.
And we are seeing that shift directly in how sites are chosen. Land is now being evaluated almost entirely on available power and proximity to transmission lines, not just price.
And the utilities are getting smarter too. They're using these rigorous intake forms and high application fees, sometimes 7 figures, just to filter out the speculators.
You can't just casually reserve power capacity anymore.
No, that age is definitely over. They're only focusing on serious, well-funded projects.
Which brings us to the next logical step. If you can't rely on the grid, GCs now have to deliver the power generation on site. The data center becomes its own mini power complex.
That's right. We are seeing a huge surge in demand for utility contractors, welders, pipe fitters, all needed to install on-site natural gas generation and massive diesel backup systems.
The scale is just unprecedented.
It is, and the knock-on effects are huge. We saw a great example out of Western Pennsylvania. They're planning new gas-fired power plants,
Right.
like the 4.4 gigawatt facility at Homer City, just to power new data centers.
And that's going to prompt a surge in new gas well drilling.
Which, as you can imagine, creates significant local controversy.
Right, and that controversy is exactly why the green pivot isn't just a nice-to-have anymore, it's a requirement to get a permit.
It's essential. Developers are now mandating massive solar arrays and battery storage systems BES as part of the initial bid. Solar subs have to be partnered with the GC from day one.
I also see a lot more talk about nuclear power in the materials.
It just makes sense. Nuclear is dense, it's clean, highly reliable. It aligns with the net zero targets of the big tech companies. The big story there is the interest in small modular reactors, SMRs.
They can provide, 1.5 up to 300 megawatts? That sounds perfect for a data center campus.
It is, potentially. But the risk profile is different. Commercial deployment in the US is still facing a lot of regulatory hurdles, high upfront costs. Reliable deployment isn't really expected until 2030 at the earliest.
The GCs need to be careful if a project is banking on an SMR showing up on time.
Exactly. We've gone from worrying about HVAC to managing a potential nuclear site.
That's a perfect transition from the electrical revolution to the plumbing revolution, the liquid cooling shift.
Yeah, the plumbing is becoming just as complex, if not more so, than the electrical. The power density we talked about, it just necessitates a total shift in how you manage heat.
So what's the reality on the ground today? What are GCs actually building?
Today, they're building hybrid systems. It's usually a mix, maybe 70% liquid cooling and 30% air. And the liquid cooling is mainly 2 technologies: rear door heat exchangers, or RDHX, and direct-to-chip DTC.
Okay, what's the difference for the contractor?
Well, RDHX is basically a big heat exchanger on the back of the server rack. It needs specialized piping and a high-volume chilled water supply right to the rack.
So an advanced form of HVAC planning.
Kind of. And DTC, direct-to-chip, is where the real plumbing expertise comes in. This is extremely precise piping and manifolds inside the server enclosure, bringing coolant right to the CPU. It's far more efficient, but you need specialized pipe fitters.
And these are the new default standards.
For any new high-density build, yes, absolutely.
But looking ahead, it seems like the industry is moving toward immersion cooling.
Oh, yes. Immersion is the future, especially when GPUs push past, say, 150 kilowatts per rack. This is where you literally submerge the hardware in a special dielectric fluid.
But that creates some pretty major construction challenges, right? I'm thinking about the structure itself.
Exactly. I mean, we're talking about structural design challenges you'd never expect. These cooling baths, full of fluid and equipment, they can weigh up to 4 metric tons.
So a structural engineer now has to account for a server bath.
It's a radical departure. It requires significantly reinforced flooring. That's a major new cost and a big complexity for concrete contractors who are used to light floor loads.
And we have to connect this back to the political risk we talked about: water.
Spot on. The cooling strategy is now directly linked to winning local approval. A traditional data center can use up to 5 million gallons of water a day for evaporative cooling.
5 million gallons.
Yeah.
A day.
Yeah. But these new liquid cooling methods, especially closed-loop DTC and immersion, they use minimal to zero water. That dramatically reduces a huge political liability.
Speaking of complexity, these hyperscale builds just integrate so many technical demands. You've got proprietary power grids, new cooling infrastructure, shifting regulations. They're monsters.
They absolutely are. And if you are trying to manage these immense multi-billion-dollar projects, I mean, coordinating all those different subs for concrete, solar, natural gas, proprietary plumbing.
And you're still doing paperwork on a clipboard.
Whoa.
Or relying on a bunch of siloed spreadsheets.
You are going to get buried. Just buried by administrative chaos.
You just can't afford that kind of drag when you're building the future of AI. You need tools that match the complexity. That's why we partner with Smart Business Automator.
Smart Business Automator takes that whole administrative load off. It streamlines your change orders, makes sure permitting documents are updated in real time, and manages communication across thousands of moving parts.
It helps you automate the admin so you can focus on managing the real project risks.
Yeah.
Material shortages, safety, scheduling. Visit smartbusinessautomator.com to learn how they can de-risk your next complex build.
All right, let's pivot back to those project risks, specifically the permitting and political risk. This is the biggest warning we have for GCs.
The community can be the project killer.
Absolutely. And the water footprint is the rallying cry. Northern Virginia, the data center capital of the world, consumed nearly 2 billion gallons of water in 2023. Loudoun County alone used about 900 million.
When your local utility bill spikes or water reserves dip, that creates potent political leverage.
It does. And we've seen candidates win elections campaigning against data center expansion. So what's the critical risk mitigation advice here for a contractor?
It's simple, but it's essential.
You have to account for permitting delays in your contracts, and you have to hold the line on mobilization. And this is the warning. Do not staff up your crew until the town signs off.
Because if you get stuck with an expensive, idle crew waiting for a signature,
your margins will just evaporate overnight. These projects are prime targets for protests and environmental reviews that can stop everything.
So how do you get a competitive edge when you're bidding on these projects?
You solve the political problem for the developer before it becomes a crisis. Builders who propose water-neutral or recycled water infrastructure in their initial plans are much more likely to win the bid. You're de-risking the project for them.
Okay, walk me through that. What does water-neutral infrastructure actually require from the contractor?
It means designing and installing closed-loop cooling systems from the start. These systems reuse wastewater and can cut freshwater use by up to 70%. For the contractor, that means specialized pipe fitting, materials resistant to chemicals in non-potable water.
A huge opportunity for advanced MEP contractors.
From a massive one, yeah.
It's just fascinating how closely energy planning and data center development are tied now. The sources point to states like Louisiana, Texas, and Virginia leading the investment.
And that's no coincidence. Markets that strategically coordinate energy infrastructure with data center planning are winning. Louisiana, for example, had record data center spending because it aligned with $5.2 billion in planned energy construction.
So power capacity planning is now the key indicator of where the money will go.
It's a fundamental indicator, yeah.
So to summarize this generational opportunity, financing demand is set to hit a record $170 billion in 2025. This entire industry is being remade by AI.
And your success hinges on mastering this new complexity, the shift to liquid cooling, building proprietary power on site, and, maybe most importantly, mitigating that political and permitting risk.
It's a construction boom, unlike anything we've seen since the interstate highway system.
It is, but here's the final provocative thought for you to consider. While the pipeline is enormous, $20 billion in planned starts over the next 6 months, the investment is highly concentrated.
How concentrated?
Our analysis shows that just 2 mega projects account for 80% of that total planned value.
80% from 2 projects. That creates high volatility, doesn't it?
It creates the potential for a data center bubble, a situation where an enormous number of projects, despite all the hype, may not actually have secured anchor tenants or real customers. They could just disappear into the ether if capital dries up. Challenge for you, the builder, is identifying which projects are backed by real sustainable demand and which are just speculative. That distinction defines the true risk in this AI gold rush.